Hello. Welcome, everyone. Good morning. Welcome to FLEXCON2020. FLEXCON is an international conference co-organized by Smart Energy Europe and Flexible Power Alliance Network, who share the common goal to engage consumers to play a critical part in the energy transition. Due to the ongoing pandemic, this year's FLEXCON is an online event where every Wednesday from 23rd to September to 28th October, a different topic will be addressed. I'm pleased to say that today we are already more than 100 participants, and it's still counting. Thank you already now for your interest in taking part today, where we will talk about flexibility markets. My name is Elies Lahmar. I work for Elies, which is a demand response and renewable aggregator and power trading company in Germany. I'm also chairman of the board at Smart Energy Europe, and I'll be your host for today. It's my great pleasure to be the host for this very interesting topic, flexibility markets, which are, of course, a very important element to the energy transition, given the ever-growing need for flexibility to help to integrate the ever-growing share of renewable energy sources. Today, we have a great lineup of speakers, as you can see on the slides, and which I will introduce when they start their presentation. They will talk about their experience with flex markets. They will talk about the value of flexibility in general, about the future flex market opportunities, and about how to best unlock flexibility. Before we start, I would like to highlight a couple of things. So you know, slides and recording will be shared with participants afterwards. Questions can be asked to the speakers via the question pane on the GoToWebinar dashboard. We will have a format of 15-minute presentations and 15 minutes Q&A, where I will pose a selection of the questions from the audience to the speaker. There will also be votings, as you have already experienced throughout the sessions. Very much encourage you to participate. And the first voting has already taken place, and I see that we have a variety of participants today in this webinar. So that's very good to see. With that introduction, I would very much like to start with our first speaker, who is Helena Gerard. She has received her master's degree in commercial engineering, specializing in finance from University Leuven in 2007. At the same university, she also received an advanced master's in financial economics in 2008. From 2008 till 2014, she worked for the energy company GDF Suez. She occupied several positions in the field of sustainable energy, price, product design, and portfolio management. And in 2014, she joined EnergyVille as senior researcher, where she's still working today. And there she is responsible for the EnergyVille roadmap on energy market design. She's involved in both international and national research projects, as well as commercial contract research in the field of market design and system operation. She participated, amongst others, in the European projects Evolve DSO and SmartNet, and she currently leads the work on market design in the European projects EU SysFlex and OneNet, and is also chairing the Bridge Working Group on Regulation. Helena, the floor is yours.
Okay, thank you, Andreas. So good morning, everybody. So thank you, Andreas, for the nice introduction. So in the next 50 minutes, I would like to tell you a little bit more about some smart ideas you could do when you want to unlock flexibility. In particular, flexibility that is provided by renewable energy sources. So I don't know if you can see the next slide. Okay, but before going into detail about flexibility, let's talk about a challenge. What you see here, it's a typical house from the 70s, which definitely or desperately needs some renovation to use some new technologies, but also to apply or to comply with the new standards. And then often you get this. What you see here is unfortunately a typical example of what can happen when a renovation goes wrong. You see that a lot of functionalities have been added, new materials have been used, but still, if you look at it from a distance, it does not look that great. What you probably, if you would have done a renovation, would have liked to achieve is what you see on the right. And I think everybody would like to live in the building on the right, but on the left, not so sure. So why am I showing these pictures of buildings when we're talking about flexibility? Because this is exactly what we see when we talk about the design of system services. Today, we have already a set of system services that is typically designed for technologies of the past, but also for the problems of the past. So we all agree that we need to upgrade and change them, use new functionalities, use new technologies, change the scope, add new services. But what we often do is the approach on the left. So we make incremental changes to this design of system services. We add a functionality to incorporate a new technology, or we change a little bit the scope, we change slightly the procurement cycle, a little bit trial and error. But then you might end up with actually quite long implementation paths with a lot of incremental changes, which are costly. And in the end, you risk to have the building on the left instead of a set of system services that look like the building on the right. So what you actually want, if you talk about system services for tomorrow, is not incremental changes all the time. You want to have a fundamental new design. Or, to say it in a more, I would say, academic way, if you want to design or upgrade your set of system services and really make sure that the technical potential of flexibility is translated into the right market potential, you want to come up with a complete new design that takes into account innovations at different levels. So when we talk about innovation, we see 4 big axes that you should take into account. We see innovation at the level of new technologies, innovation at the level of system operation, innovation at the level of business models, and innovation at the level of interactions between stakeholders. In the next slide, you see what this innovation means. We'll not talk about all the elements on the slide, but the main message here is that there is a lot of innovation. There are a lot of new elements that you could integrate and use to design your products, to design your market for system services. And you see immediately here that the risk that I was talking about when looking at the picture of the buildings, that is quite obvious. And today, you try to use or to integrate elements that allow AI to drive your market. Or you also, on the right, try to do something for congestion management. Or maybe you also add some additional elements related to TSO-DSO coordination, or maybe you want to do something with energy communities. All the elements we have been dealing about, it's a lot. And indeed, you risk that you need to make continuous changes to your products and markets, which is not a good thing, not only for costs, but also not for investors, because it's not very stable. And also regulators prefer that there is at least a certain level of stability to make sure that we do not endanger security of supply or the security of the system. But okay, now we have seen the challenge. We see there is a lot of potential to innovate, but how can you indeed make sure that we have a good plan that immediately makes us future-proof? That's something that we have been working on in EnergyVille on this question already for a couple of years. And the way that we approach it is by using the EnergyVille market simulator. The advantage of this market simulator is that it takes into account all those innovation aspects that we talked about in previous slides, like different energy carriers, different services, different actors, and that we try to upfront calculate the different options that you can have for a product or a market organization. So it's not just trial and error. No, you have a set of options. you can immediately calculate the result or the impact of those options, so to see what is typically the amount of flexibility I can use, what is the average price of my flexibility, and do I actually cover with this flexibility the needs of the system? And so you can make a better decision. How should my design look upfront instead of first trying and then adapt and try again? Another aspect which is very important here, it's not just about upfront calculation. The simulator also integrates the modeling of the behavior of the actors and the market participants. And this is really the catch. Because you can try in a theoretical and academic way to model a system, it's interesting, but it does not capture the real behavior of your actors. And it's clear that with a similar system, in case you have a lot of small flexibility providers or you have one big incumbent, the outcome of your market will already be very different. So it's extremely important that you also capture that almost like psychological effect of the actors that are basically impacted by the design of your product and your market. Within the simulator, the way that it's approached, it's not by just having a lot of psychologists behind. No, what we do is to simulate a sequence of events that you see on the bottom of the slide. We try, for example, to mimic the outcome of the day-ahead market that has a certain impact on the outcome of your flexibility. It makes some flexibilities available, some others are already reserved. And that also tells you how much flexibility is still left for another market sequence. And of course, if you then change the way that you organize these markets, or you change the interaction between the markets, you change some of the rules, you will see that flexibility will shift from one market to another market. And this whole interplay of markets, product, market design, and the reaction of your actors, that's actually what you should do in order to avoid, I would say, a complex market, which is not, probably not unlocking all the flexibility potential you might have. I just show here a small case study that we did to illustrate how this looks like. So the question here is, how can you increase the participation of renewable energy as source of flexibility? We see that there are a lot of obstacles. When you use RES as a flexibility source, often there are still restrictions on market access, or the contracting frequency is not optimal, or the combination of markets, or even the potential of combining different RES assets is not possible yet. And those obstacles, you see them from the moment of pre-qualification until bidding and activation. So on the slide that I'm showing you now, you see the outcome of an exercise on the impact of the procurement frequency. You see on the right some installed capacity of solar and wind, and on the left you see the impact if you do a daily procurement compared with a weekly and a monthly procurement. And it's clear that if you have a daily procurement for both solar and wind, the participation is massive. Compared to weekly, it's still very limited, and monthly, it's almost nothing. If you look at the other side of the slide, you also see the impact of the seasonality of the technology. And there you see that the impact of seasonality is there, but it's much less important than the procurement frequency to really unlock the value of RES. If we then go to the next slide, why is this important? It's clear that if we see, if we go towards a daily procurement compared to the monthly procurement, we see that there is a much higher differentiation in the offered volumes and prices when we see a daily procurement. And this has a big advantage. It has not only more, it does not only show that there is a larger set of offering, the offering is also more stable, and the prices of the offering are also lower. And this has obviously a positive effect, not only for the system operator, but also for the market operator. And in particular, it shows that for an investor in RES, this market setup gives them a drive to have a stable business case and also to invest in additional renewable energy. So you see that for everyone in the market, every actor, it's actually interesting if you do a proper design compared to, I would say, a more old-fashioned. This was an easy example, just to illustrate the power of doing a simulation and kind of play with the different aspects of a simulator. That brings me to a couple of conclusions. So basically, due to the fact that we have imperfect information, strategic behavior, all those technologies, it's very complex how to design a future-proof flexibility market. And in particular, if you want to translate that technical potential of RES, but also other technologies, looking at storage, but also power to X, you need advanced modeling to tell you which of all those options brings you the most value. And the real difficulty there is often that you deal with behavior, you deal with gaming, you deal with real actors, not just with only technologies. You deal with portfolios. And that's something that's very hard to capture, but in case that you can model that, it gives you much more guidance how to move forward. And as a result, it gives you also potential significant cost reductions, because we really see a difference in efficiency of the implementation path and an increased, I would say, volume, which leads to lower costs for the flexibility procurement. So when we talk about unlocking flexibility, it's not just new services, market platforms, and rules for interoperability. These are all still extremely important, and I guess the next speakers will talk about that. But we also see that the key enabler for a smart design is to think about what type of country do I have, what type of technologies do I have in this country, and how does this have an impact on the interactions between the actors in my system. And if you have that exercise clear, then it's really an enabler to move forward. So to sum up, if we talk about innovative design of system services, take definitely the following 4 elements into account. The potential of new technologies, not only the ones we have today, like wind and solar, but also new ones that we envision, like power to hydrogen and other power to X options. The relations between the different products and markets, it's extremely important. You do not want to have one market to dry up the potential of flexibility in another market. And this interplay is different for every country. Also, the impact on the behavior of market participants as a third factor, it's really important. And then, of course, also the interaction between the market participants, because one action of one market participant will trigger another action of another market participant. So this was it for me. I hope that the message was clear. I hope that you remember of this talk that always, let's say, think about the right building and not the left building, and that when we move forward with flexibility markets in the future, that we do that in a smart way and not, I would say, in the trial and error way, which could lead to, I would say, disappointing results. Thank you very much. And I think that there is now a poll, and I'm curious to see what will answer. Thank you.
Thank you. Thank you very much, Helena, for this very interesting presentation. It feels to me that there's also some sort of a mindset change possibly required in order to design system services and procure them in the most efficient way. And I think we'll have a chance to further discuss this now in the next session. But let's start with this next poll that we have in front of us. What is the biggest challenge for system operators when designing robust and future-proof system services? Please take your pick, and we'll give it a few seconds so that we can see the answer. Oh, it's already there. Very good. And it's a very clear answer. It's a mix of flex markets, tariff incentives, and grid investments that is the biggest challenge. And I think the first question that I would ask you, Helena, is actually related to that to some extent, and also maybe enables us to understand a bit better your proposal. How would you differentiate your model from the model that is currently used by system operators?
Thank you very much, Andreas, for the question. What we see often today is that system operators look at the potential of technologies available in a country. And so they look at the amount of wind and solar, and then they say, okay, we have so much MFRR needs. So we have that technology, it has, let's say, a load factor of X. So we think that it can cover for 20% our needs. But what they forget is that those wind and solar is part of a portfolio, and that the catch whether this renewable energy will actually answer or will help you, it really depends on what the strategy is of the aggregator or the retailer that is basically owning those assets. So to capture that behavior, that strategy, and that strategy is not just driven by the technological element, it's also driven by the financial incentives, the other markets those actors play in. That's a much more complex question than just checking is wind has the capabilities to provide downward flexibility. And if you capture that almost interplay of actors, and that's what our model is doing, and which other models mostly don't do, will often give you complete different results. So I would say that's exactly the differentiator, but it's also often the gap that we observe.
Okay, very good. Well, let's take a couple of more questions from the audience. I actually have a remark from someone saying, and I summarize, it's of course a challenge to replace a whole system. So it's a more piecemeal approach that would be required. But also the market develops through the actions of many different participants. So given that statement and that question, what do you think? How can this market in practice be implemented, or this change that you propose?
Yeah, so let me first say it's not one or the other. Eh? So I'm not completely against small. Yeah, of course you need to test something. Eh? If we do not test in a very small demo setting that a windmill can provide downward flexibility, yeah, it's of course ridiculous that suddenly you launch a large system analysis. So that still remains valid, those initiatives by smaller players. But what we often now see is that at a certain moment you need to stop and to say, now we have all those different options, like I mentioned, let's put them all together. And then if from a system operator, you see there are in many countries that you have a limited set of system operators, or at least they talk together, that driven by those system operators, you can organize a kind of consensus for a proper market design and product design. There are not, I would say, 2,000 voices in that debate, but of course they need to take the input of all those, I would say, smaller developments. But yeah, it's a bit like an if you go to a classical concert, yeah, you have all those musicians, they're all expert in their field, but in the end you need to have one guy who kind of leads the music play in order to make it sound nice. And that's what we need, a kind of architect of the system. Often this architect is the system operator or the multiple system operators backed up by the regulator. And that architect, they need a model and they need to know what do I need to choose between all those options.
Okay, thank you very much for that. I have a quite specific question from the audience, which is, do you see an overlap between your model and the D3A.io simulation software from Grid Singularity? I don't know whether you're familiar with this other software. If you are, you could probably answer the question.
I heard about it, but I'm not exactly familiar with it. So I would actually invite the person who has has put this question, maybe send me an email, then I check it with the experts, making sure that what I say is correct. But I would say that it's not overlapping. There are synergies between the two.
Okay, let's take another question then. How is the strategic behavior of different parties and participants modeled in your model?
Yeah, so the strategic, well, first the question is, what is strategic behavior? Eh? Is that, some people consider strategic behavior the same as gaming, which is not the case. Eh? Gaming, there we would say it's almost abusing holes in the organization to let's say, to make substantial more money than we all feel is justified. Strategic behavior, I would say it's more a positive thing. It's what every company should do. It's defining your strategy in order to see where your flexibility has the highest value, which is good for the flexibility provider, but often also in the interest of the person or the market operator that needs that flexibility or that will organize that flexibility. So that said, the strategic behavior, we try to model the different bidding curves and bidding strategies of participants. And the way that you do that is to look at, in a certain country, what certain flexibility providers, typically his portfolio of assets, how do those assets look like? What could be a portfolio bidding strategy? Yeah? So when is it interesting to combine certain assets, when not? What are the different market rules of that country? And then you can basically almost calculate which combination makes the most sense. So it really is based on the asset portfolio of a certain provider of flexibility and the combinations these assets make, and also the relation that one single flexibility provider has compared to another another flexibility provider. And then you basically end up with a kind of merit order for different markets of different flexibility providers. And then, yeah, you can see how they, which price will form in which market.
Okay, great. Thank you very much, Helena. Thanks for your presentation and for the Q&A. I think this was very interesting and gave us a nice kind of framing and setup for the presentations that we will hear now. So thank you very much for that. Next one. Thank you. Next one is Hallstein Hagen from Notes. We will talk about integrated flexibility markets. And Hallstein is a senior consultant at Notes. He has since 2016 been part of ACTA Energy flexibility project that led to the establishment of Notes together with Nord Pool. Hallstein has long experience delivering energy trading and risk management software to the energy sector. He has international experience from finance and commodity industry from his time back at Reuters. And Hallstein holds a bachelor in marketing from the Norwegian School of Marketing and Business Studies and Banking Studies. Thank you very much, Hallstein, for being here, and I hand over to you for your presentation.
Thank you very much, Andreas. It's a pleasure to be here at FLEXCON again. I think it's about almost 2 years since I last presented at FLEXCON. And since then, we have been on a journey at Notes, and a journey I'd like to share with you. First of all, I'd like to say that we believe in creating a marketplace for the future which will support the drive to an emission-free society. This is core. This is why we wake up in the morning and go to work. We believe that unlocking the true value of flexibility is the way to go by providing an open and transparent, integrated, but above all, an independent marketplace for flexibility. And we do that by providing facility where sellers and buyers of flexibility can meet. Buyers of flexibility will mostly be grid operators, and in this respect, the DSOs, and sellers, well, there is a lot of them out there. If we look at the changing face of the energy system, conventional generation being decommissioned as a result of our drive to net zero, we see an increased share of renewables being connected to the system, driving down the cost of energy. We are seeing negative prices. We're seeing wholesale prices going down. So energy has, in many ways, not been cheaper than it is today. We see the technology where it's estimated that 50 billion devices will be connected by 2030. And I must say, I'm currently doing a renovation of my kitchen, And the most difficult decisions to make is whether your fridge and your dishwasher should be connected to internet. This gives the consumer a greater control over when and how they consume energy. Really challenging results for the DSO to balance the network, basically because they are losing access to ancillary services from large-scale generation. So it's quite interesting to notice that while the price of energy is going down, the cost of maintaining and operating the energy system is going up. This, of course, if you add to that the effect that the coronavirus have had to the market, where we in the first month of Corona saw a consumption going down by 14%, CO2 being reduced as much as 39% up until April, and solar generation up 28%. So this postcard for the future really highlights the lack of flexibility in the system. And this lack of flexibility has a big impact on the grid and operation of the grid, where we see the TSOs are struggling. The German dispatch cost reporting a record high, emergency actions being taken by TSOs in different areas. So this national issue might actually have a local solution. Why is that? Yes, because more than 80% of the renewables are connected to a local or regional grid. This brings me over to discussion of a market. So I looked up on Investopedia, what is a market? And it's a place where buyers and sellers can meet to establish a price of, in our case, flexibility that is determined by supply and demand. And we believe that the market in this respect should only do that function to be this meeting place. We see that the establishment of a market for the regional and local grid operators is a cultural travel for the DSOs. They are not used to buying services like this. We see that we also see that the clean energy package is supporting this change, and they highlight the use of a market-based acquisition of flexibility, in addition to making room for the role as an independent aggregator in our system. So to summarize, the trends that we are seeing, the challenges we are observing, it's clear that flexibility is key. And it's also key that flexibility is made available to all levels of the grid, so that it can make a most cost-effective and best use. And at this point, I want to stop a little bit in my presentation and present the poll, which should come up on your screens. And I'm really curious to see where the audience is leaning in terms of what financial incentives is most promising helping the energy system stability. You see your choices on the screen. And if we just hold for a second, we should be able to, or a minute to be honest, we should be able to see the results. Did we get the results for the polls? It's interesting to see that as much as 49% believe in variable grid fees, energy prices, and energy taxes, followed closely by a payment of flexibility. It shouldn't come to a big surprise if you switch my screen back again, please. That we will advocate for a market-based flexibility price. the different options, the different methods of accessing flexibility will address different type of flexibility. To address the implicit flexibility, of course, the time-based tariffs will probably change consumer behavior, but it hurts because the higher price needs to be paid by everybody. We have observed, especially in the Nordic countries, that the use of interruptible tariffs as a security measure has been used where the DSOs get access to flexible resources, and the price they pay for that is not very transparent. It's been paid by a discount in grid tariffs, and the activation of such flexibility is obviously zero when they activate it, but the cost is often hidden. A long flexibility market where the buyers can buy availability contracts ahead of time to get control over the flexibility, combined with a short flex activation market, is where we believe we will get to a situation where we unlock the true value of flexibility. And Helena talked about a new house and a new drastic way of looking at the market. And in November 2 years ago, we launched our bottom-up market design, which is such a new house. And it works the way that we are starting from the bottom of the system, from a metering point, and the DSO or regional DSOs can then define the congestion zones. When they define the congestion zones, they upload the coordinates of this congestion zones to the nodes market, and we create grid locations. And at that moment, we have an order book, a local order book. And we can start trading and we can start forming that price. So we are, in many respects, creating a market where different type of flexibility can compete on a level playing field, where the right type of flexibility can be procured at the right price, in the right location, at the right time. We are testing and developing this market through cooperation with many other players. We are testing capacity challenges for the TSO in the Stockholm Flex project, where SVK, Vattenfall, and Ellevio is setting up a regional market around Stockholm. We're testing also there a market-based TSO-DSO coordination, because both the regional DSOs is going to buy flexibility in each other's markets. We have large-scale pilots in Nordflex in Norway, where the demo Agder has set up a budget of 1.7 million euros to acquire flexibility for the next 2 years. We are demonstrating flexibility trade close to real time in the short flex market, in the intraflex market in the UK, where Western Power Distribution, who is very active in buying long flex through their flexible power program, is also buying flexibility in the short time frame. And we are showing transparency pricing there, actually publishing average pricing for what has been traded in that project on the node's homepage. The alternative to grid investment is really going across all the projects we're involved in, and it's interesting to see how we can test the various part of the market design in conjunction with market that is already there. So in the Norflex market, we are in additional testing, aggregating local flexibility to the TSO's MFRR market to see how we can have an integrated approach to dealing with flexibility. And that's the end of my presentation.
Thank you very much, Hallstein, for this presentation and for taking us with you a little bit on the journey that Notes has been engaging on over the last few years. It's very good to see what that included. And before we move on to the Q&A part of this section, I would just like to say that we have currently a bit more than 160 participants in this session. I want to thank everyone for participating, and I want also to encourage everyone to ask questions through the questions pane on the webinar dashboard, so that we have a very lively discussion in the Q&A part. Let me start with one question to you, Hallstein, that is coming from the audience, which is, if we get time-based tariffs, that will lead to the automated, potentially to the automated dispatch of a huge amount of flexible resources and could create problems in the local grid. What's your view on that in terms of that problem that it creates, and potentially how flexibility markets can help?
Well, it's in my view, it's better to ask if there's one or two persons that are willing to provide flexibility for a price than to force everybody to pay a higher price. So I think what we see in the Interflex projects, for instance, we see different type of flexibility coming online. We see vehicle to grid, and we see batteries from residential homes suddenly having a place to transact flexibility. And that is, for me, a more positive. That is the carrot. The time-based tariffs, for me, is the stick.
Okay. Can you also explain us a little bit how Notes compares to COPEX, which is also one of the questions from the audience? Do you know COPEX?
I know of COPEX, but it's dangerous for me to talk about COPEX as such. But what we are doing, we are just focusing on being a marketplace where we get the price for flexibility set up. I think I need help from the COPEX people to really go into the difference.
Yeah, that's totally understandable. Let's then take another question, which is on energy poverty. The question is, how does the market-based approach you're proposing impact on energy poverty? Some people won't be able to invest in flexibility. Will they bear the brunt of the cost?
Well, they are certainly bearing the cost if we do tariffs, because then they are forced to pay a higher price at that time. So if the flexibility market is functional, we will have a transparent price for flexibility, and people can calculate their business model out on the basis of those prices. And if we have a functional flexibility market, we shouldn't have so high cost in system operations that we are seeing, and that we are hearing from the TSOs that they are forecasting for the years to come. So in the bottom line, the energy poverty will be helped by keeping the system operation cost down by allowing flexibility market where everybody can participate. Okay.
Another question is around would your new market proposal work in parallel to or in replacement of the current flexibility reserves markets, such as FCR, AFR, and MFR?
Well, what we started off 3 years ago. We started off by trading 5 minutes before the operating hour in very small scale. So the notes market can operate in any time frame, really. But in the projects, and in order not to disturb the current markets, we are closing the notes market an hour to 90 minutes ahead of the TSO markets, so that we manage to do this transition over time. And at the moment, I think that is wise. But maybe our project will learn or highlight a different way of operating, which the TSOs will be happy with. Who knows? At the moment, we are closing before the TSO markets, and we're aggregating volumes up to the TSO's markets.
Right. Let me combine two questions that came in to one, which are around the implicit and explicit flexibility. So one being explicitly dispatched and the other being reacting to price signals. Do you think those kind of different concepts, implicit and explicit, are somewhat have different effectiveness of different groups of flexibility providers? You know, so one person was asking about the question of how do you how does shifting 100,000 dishwasher operations in a city from 6 o'clock in the evening to 2 o'clock in the morning, how would that be a business? And of course, more broadly, does it impact on dishwashers, for example, or batteries or other types of flexibilities, whether you use implicit or explicit flexibility systems?
There are aggregators today who is offering convenience and convenience to their customers in order to control portfolio of appliances. And by offering convenience to the customers, they are able to offer explicit flexibility in the markets on the back of that. So I think that we haven't seen the business models on the seller side of flexibility yet. I think there will be many business models coming out as we have an opportunity to transact on flexibility markets. But not everybody will optimize based on the same parameters. The grid operators will optimize on security of supply, whether the households will certainly optimize based on comfort. I asked my wife if we were prepared to charge my electrical vehicle at a different time, and she said, no, I want to charge it when I come home, so I'm sure that it's ready. And then I asked her, if I give you 5,000 to charge it 3 hours later, would you do it then? And she said, of course. Yeah. So what is missing here is the price, and that's what we're trying to find.
Okay. Hallstein, do you see a clear rise in independent aggregators providing flexibility also on smaller scale, for example, for households that are being connected to your platform?
Yes, we do, and we also see that the introduction of short flex allows them to offer flexibility. Many of the flexibility schemes in the UK, where the DSOs are requiring flexibility twice a year, is not reachable for these providers because they are very much weather dependent, and they don't know how much flexibility they have maybe until the day before.
Okay. Another question from the audience is, does nodes follow USEF?
Nodes has a lot of USEFs in its market design, and indeed Nodes has been one of the flexibility markets that was written about in the USEF white paper. So we haven't taken the USEF and said is Nodes a USEF implementation. We come up with our own market design, but we had one of the experts of our market design group also works heavily with USEF. So there is a lot of USEF in our market design.
Okay, great. There's no further questions. Oh, there's one more. What is the minimum capacity in terms of flex that you have tested so far? And are residentials currently excluded from the tests?
It's interesting to see because the project that we have in Senja, this is where you see the northern light, and you have a fishing industry at the end of a grid connection that is being digitized and being penalized for problems with system stability. On that small island, there is also residential customers, and the aggregator or the balance responsible party there is looking at ways of listening to bid orders from the DSO on nodes, and then creating a service where they just ask the customers, "Are you happy to disconnect your heating for half an hour now? This is how much you get." And then we just do the disconnection. So there is interesting business cases coming up, also on a small scale.
Right. Let me close this part by asking also one question from my side. What do you think, Hallstein, are the kind of main hurdles that you see in rolling out these kind of marketplaces that you're currently in the process of?
It's to get the DSOs engaged. There is a huge cultural travel. Many of the DSOs are still being rewarded for building grid. They're not being rewarded for using flexibility. They're waiting for regulation, and there is a big cultural change in the buyers of flexibility. So once you get a buyer, the sellers are coming right away.
Okay.
Add to that, of course, the regulation part needs to be in place, but that is being dealt with under the clean energy package.
Okay, very good. Well, thank you very much, Hallstein. This has been a very exciting session, a lot of insights. Thank you very much. Thank you very much for that. Well, let's then move on to the next slot, which is from Elies Lahmar. He is from EPEX SPOT, and he will talk about the enera experience and future perspectives for flexibility markets. Elies is a senior market designer at the European Power Exchange, EPEX SPOT. He's passionate about the energy transition and current challenges in the power sector. He holds a degree in mechanical engineering from Mines Paris Tech, where he also studied energy economics and power markets. As part of his curriculum, he worked at ArcelorMittal, I hope I pronounced this correctly, as an energy analyst, more specifically on sourcing optimization of the steelmakers' European power and gas consumption portfolios. Furthermore, he worked at Danske Commodities, active on short-term European power and gas markets, where as a quantitative analyst, he designed and implemented automated trading strategies. Elies joined the product development team of EPEX SPOT in 2017 as market design analyst. He's in charge of business development, exploring and assessing innovative ideas, products, and concepts that will shape tomorrow's power markets. Elies particularly focuses on the development of the local flexibility market initiatives in which EPEX SPOT is involved. In this regard, he was also part of the design and implementation of the enera local flexibility markets since 2017, and I believe he will give us a lot of insight in that process. Elies, the floor is yours.
Thank you, Andreas, and thank you for the introduction. It's a pleasure to be again featured at this FLEXCON conference online, this time after a physical presence 2 years ago. So today the idea will be to introduce and present to you more insights into our vision at EPEX SPOT on what flexibility markets are, and also provide some details from our concrete experiences, such as the one from the enera project, where we took part as a flexibility market operator. Maybe a word of introduction on EPEX SPOT. It's a European power exchange tackling short-term power markets in Europe. They had an intraday, but also opening new initiatives and new concepts to develop new markets and be able to further improve the European power market design. So for this presentation, I will walk you through 2 parts. The first one is about our vision for local flexibility markets. We will remind a bit of the context and the main developments we see in this field, and some of which have already been introduced in a great way as part of the two last presentations. And in a second stage, I will walk you through one of the most concrete implementations of local flexibility markets in Europe, which is the enera project in which we took part in Germany. So let's first start with the vision for local flexibility markets. And one very important context element that everyone should have in mind, and that was already mentioned, let's say maybe in another way, in earlier presentations, we are really right now in the process of a paradigm shift in the electricity industry as part of the whole decentralization trend that we see. And this shift is about a transition from an, let's say, old, centralized, dispatchable, unidirectional, large-scale and fixed electricity system that is transitioning into a new distributed, intermittent, bidirectional, small-scale and on-demand system through the development of renewable energy sources that is led by the ambitious goals towards net zero, the decentralization, the fact that there are increasingly more actors and especially increasingly more small-scale actors that are being developed, more flexibility, more small-scale participants, and also more variability. And this is really a profound shift in our industry that will have very strong impacts on the markets, and that calls for changes and new market structures, work on the market design, as was said earlier, in order to accommodate and to create a future-proof electricity system and system management. So if we take a look at the current situation and the future outlook, basically we have a lot of challenges, as I already mentioned, the decarbonation challenges, the decentralization challenges and opportunities, but also increasing congestion management costs on the transmission level and increasingly more on the distribution level. And to face these challenges, we have a new regulatory framework that was released, the Clean Energy Package, that provides very important guidelines that will drive the market design, the experimentation, and the demonstration that is currently taking place. So we have a supported role for demand response and aggregation, new guidelines for the TSO and DSO coordination to be able to take into account all these challenges and changes in the electricity sector and electricity grids. We have provisions for market-based redispatch and market-based congestion management that really lead to thinking about how to organize such markets, and incentives for system operators to consider flexibility procurement and optimize grid investment costs. So currently there are still many market design questions that are open and that at EPEX SPOT we try to tackle regarding the organization of the coordination between TSOs and DSOs, regarding the flexibility market timeline. Is it a long-term market? Is it a short-term market? Is it a mix of both? The links between these flexibility markets and the wholesale market, or even other types of ancillary and system services. Then a pure product design question on the flexibility products that should be displayed, and about the standardization of these markets and these products. So the current situation in Europe is that there are more than 100 flexibility projects that range from theoretical projects, simulations, but also demonstrations, and increasingly more leaning towards commercial projects with really a high number of use cases that are tested, and that should identify and bring the most value to the European electricity system, and in the end to the end consumers, some of which are the market-based transmission redispatch market, some market-based replacement of administrative renewable energy sources curtailment, but also use cases around grid reinforcement deferral or grid maintenance management. There are many more use cases. The general idea is that there is a need to converge and to establish a market design that will allow for this transition of the sector and towards a future-proof European electricity market. Now at EPEX SPOT, we have invested some time in recent years in order to define and refine our vision for the local flexibility market. And in our perspective, it is about the implementation of a market mechanism. So a market means really putting supply and demand together in order to derive a price and such a market should be able to efficiently centralize local flexibility resources where and when needed for the congestion management use case, to facilitate the grid-oriented TSO-DSO coordination and optimization, but also to foster the development of new decentralized flexibility resources that we see as a really important development for the future. And to do that, we believe that a flexibility marketplace should bring the right standards in terms of transparency, openness to different and all technologies that can provide flexibility, standardized products that simplify the market processes and allow for different market participants to optimize their assets, a neutral market operation that also provides clear price signals for flexibility and a clear contractual framework between the buyers on the one side, who are the system operators that need flexibility service to manage their congestions, and on the other side, the flexibility providers that are able to provide the right product and the right service to the system operators. So if we take a look at the diagram here, there are two dimensions. The vertical dimension with the different actors in this market and the right systems to steer this market. And on the horizontal side, we see the timeline of the market. So in the long term, we believe that there is a need for certification of the different assets that are able to participate in such markets. And also there can be a reservation of flexibilities that will create a situation for the system operators where they know that there will be flexibility available. And in some of the use cases, this is quite important. Then there is a short-term time frame for the market where operationally the different system operators in a coordinated way will assess their short-term needs for flexibility based on the latest forecast and the latest grid calculations, and they will be able to reflect those needs in specific markets and in specific order books, in which the flexibility providers that have been certified will also be able to send offers, and there will be a matching of such offers that will then require flexibility providers to adjust the schedule of their assets in order to deliver the service that was contracted with the system operators, that will then verify the flexibility delivery and make the payments for such delivery. And in terms of systems, there is a need for visibility over which flexibilities are available and certified. This can be done through such systems as flexibility registries. Then there is a need for real marketplace to be able to centralize the flexibility offers and to make transactions happen between the system operators and the flexibility providers. And then there is a need for a certain number of post-trading systems in terms of verification of delivery and also settlement of the different transactions. So this is let's say the flexibility market concept that we are working on with the right systems, with the right market design, and there are many questions on the market design, on the products, on the links between these markets and other markets. And one of the main concrete implementations for us has been really the enera project in Germany that was about setting up, from EPEX SPOT perspective, setting up the flexibility market that will create a link between transmission and distribution system operators on the one side and flexibility providers on the other side. So maybe a word on the enera use case first. It's a market that was developed in the northwest of Germany, in a region where there is a lot of wind production that is triggering new challenges for the system operators. So it's a region in Germany where there is a lot of installed wind capacity that creates higher costs for the end consumers, an increasing share of renewable curtailment, and also a strong coordination need between the system operators at different voltage levels. So taking into account this background, the enera project was set up back in 2017 with the idea that there is a need for new innovative solutions to tackle this situation of large renewable infeeds that are creating new congestion issues for the market operators and the grid operators. And therefore, there was a program in Germany called the SynTech program that fosters different pilot projects across Germany to find new and innovative solutions to these challenges. And as part of this project, we have really considered flexibility as the ability to modify a supply or a demand in response to an external signal, such as a price or an activation, with the aim of providing a service to the energy system, and in this case, a service in terms of solving a congestion issue that the system operators are experimenting. And the main questions that we have tried to explore as part of this project that is supposed to end at the end of this year is what price should be put on flexibility, when and how long should it be used, and how to integrate the decentralized and localized flexibilities as part of a market platform that will be useful to system operators. So in terms of organization for this local flexibility market, on the one hand, we have gathered a community of flexibility providers with more than 360 megawatts of certified flexibility from different types of technologies, renewables, batteries, power to gas, some industrial flexible loads, and some biomass plants coming from 6 different flexibility providers. On the other hand, we had flexibility demand coming from 3 different system operators: TenneT Germany at the transmission network level, and 2 distribution system operators, which are Avacon and EWE Nets. And the idea was really to bring a flexibility marketplace that will make this supply and demand meet with a trading system, standards, transparency, coordination, neutrality, and a contractual framework that will allow such transactions to take place and to help the grid situation in that region and to avoid unnecessary curtailment of renewable energy sources. So if I take now a stance on the summary of the enera facts and achievements. So as I already said, the project started in 2017 with a large design phase, which was followed by an implementation in 2018, demonstration phase that started in February 2019, and that was terminated at the end of June this year. And now we are currently working on the assessment of the project, and there will be reports published at the end of the year, so stay tuned, with the main outcomes and the main learnings from this project that are indeed a very important experience for us and for the development of flexibility markets in Europe. So as part of the project, we have been able to test new systems, competencies, and a real end-to-end process from the certification to the payment of flexibility with a new market design, a TSO-DSO coordination that has been put in place, a verification platform, and a flexibility registry that were developed as part of the project. New competencies also for the system operators. So it was mentioned that the system operators and especially the distribution system operators need to develop new competencies and also look towards the usage of flexibility. And this was done with a new forecasting and steering and communication technologies put in place. And of course, we have also established a full contractual network for the trading of flexibility. So if we take a look at the figures, we had 9 market participants, 3 system operators and 6 flexibility providers, 23 local market areas, 360 megawatts of certified flexibilities, and along the demonstration, more than 4,000 orders and 130 transactions that led to congestion management cases and the alleviation of grid issues for the system operators. So there were really many benefits that came out of the project, both for the system operators, the flexibility providers, and for EPEX SPOT in terms of market design, in terms of making the right choices to set up the market, but also to develop trading systems that are adapted to this new kind of market between flexibility providers and the system operators. So for us, it was a very important milestone, and it is a very important milestone for the development of flexibility markets that really goes in line with the concept that we have defined and which creates a concrete case for a success of such a market on a technical level, but also for the development of solutions to alleviate congestions in the grid. So this is it for my presentation. So thank you very much. I think we can take questions, but we have also prepared a small poll that maybe we can display because I'm very curious to get the opinion of the audience on what is the most important enabler as for the development of flexibility markets going forward. So there are 4 proposals here: the standardization of products, stronger incentives for DSOs and TSOs to procure flexibility, stronger TSO-DSO coordination, or the emergence of market platforms.
Thank you very much, Elies, for this presentation. And whilst we wait, let me also say that I think it was very useful to see how you explained the overall vision and concept that EPEX SPOT has in this regard, and also then seeing how you have already practically implemented it in this particular project in enera. And I also would say it's a very good question here to ask, because it's of course one of the big questions that we have: how do we further push this development on flexibility markets? So there you go. We have the answer. The most people think that stronger incentives for DSOs and TSOs to procure flexibility would be the biggest enabler. Thanks everyone for participating in this. Yes, Elies, you wanted to comment as well?
Yes, I wanted to comment the result, and this is also linked to the question you just asked. Indeed, in terms of challenges for the development of flexibility markets and the further development, I would join also Hallstein's assessment from earlier that the correct incentives for the system operators to procure flexibility will really be key in the future in order to roll out such a system, especially on the distribution side. So it's difficult to make a general assessment, of course, because there are a lot of specific cases throughout Europe, but there is a kind of cultural change towards flexibility that is currently starting to shape, and that need to be further nurtured by the regulation in order to truly enable the use of such a flexibility at all voltage levels, and also to develop further the coordination between the different voltage levels, and especially the TSOs and the DSOs, to reach an optimal market design and optimal processes to make use in the best way of the available flexibility, and to foster the development of new flexibility resources. So I am not surprised with the result of the poll.
Me neither. Thank you very much for that. And I agree. It's a very similar conclusion that you draw from also what, and the audience obviously also draws from what also Hallstein said earlier. We have a number of further questions that I would like to get into from the audience. The first one is one on market size, and whether you have an estimation. What is the market size for congestion management and redispatch?
Indeed, so there are really different perspectives that we can take. There are figures for the congestion management costs at the transmission level by system operators, on the transmission level, the TSOs. So in Germany, we know that the situation is the most critical in Europe in this perspective, with more than €1 billion that is spent each year for congestion management and redispatch activities. In the UK, the situation is also maybe one of where there are a lot of needs, with several hundreds of millions of pounds each year dedicated to this. And the figures are also increasing in a number of different European countries. On the distribution level, these problems are also increasingly emerging. But what is important to understand is that with the decentralization trend, there is going to be a big strain on the distribution grids going forward, with more resources connected to the distribution level, be it renewables, electric vehicles, the electrification of heating, or a number of different developments that we see as part of the decentralization trend. And there, I think the question will really be about striking the right balance between using flexibilities and further building the grid. So building the grid is very important because it provides really a safe way to manage security of supply. But we see that there are increasingly more opportunities for using flexibility, new platforms such as the one we develop and we are able to roll out to really seize these flexibilities. And therefore, it's going to be about striking the right balance between the use of flexibilities and the optimization of grid investments that is also a requirement of the clean energy package.
Okay, thank you very much. We have a number of more questions. What do you say to the point that reservation for congestion capacity conflicts with reservation for reserves? I'm assuming it's what is meant here is balancing grid reserves overall. So do you see that conflict? And if yes, how do you make it encouraging to also increase the liquidity in the congestion market?
So as part of the enera project, we have mostly focused on the activation side, because the congestions were really forecast by the different system operators in the short term based on the wind forecast. But in general, it's a very good question, because the reservation of flexibilities is an important feature of our flexibility markets, and especially useful for some of the use cases around local flexibility. And I think there is this is the link to balancing markets is very important, and it's a design question. How do you create markets that will be the most efficient and coordinate the best between different system services, balancing and congestion management, for example. So I think this one can be tackled through a better coordination between the TSOs and the DSOs, because on the local flexibility side, and especially for reservation, it's often useful for DSOs to manage future grid congestions that they expect. And the balancing at the moment is the responsibility for the transmission system operators. So the idea indeed is to try and create a market that will be able to properly coordinate those needs, and certainly having totally decorrelated markets and contracts can create some conflicts on the flexibility provider side that will then not really know which contracts to engage in. So there, I think it can be tackled through improved TSO and DSO coordination, but it's really an open point at this stage.
Yeah, I suppose it's also a question of are you allowing to stack products, so doing several services at the same time. Do you also have a view on whether that would be possible?
Indeed, in the enera project, some of the resources that were certified were also participating in other ancillary services such as reserves. So at this pilot stage, what was implemented was that basically the information of the activation on a balancing bid, for instance, took precedence, because we were only in the pilot stage, let's say. And I think really, in general, value stacking is something quite important on the flexibility provision side, because it allows to optimize the assets better and to get higher revenue out of the optimization of the assets. But then it should be done in a smart way, so as not to endanger the grid situation. And obviously, let's say conflict cases should be studied in real detail to set the right priorities in case there is a need in one direction for one system service and a need in another direction for the same asset. And then if the needs are in the same direction, there can also be some optimization in terms of payments.
Yeah, I see. There's a lot of important questions that still need to be tackled. This actually fits to a more general question that also comes from the audience. What do you see the role of EU legislation in this context of these markets to develop? Are we going to let market operators in each country to develop these marketplaces in order to ensure transparency and central management of these markets, or how do you see this further evolving?
So indeed, in terms of EU regulation, so there is already, let's say, a first basis, that is the clean energy package that I mentioned in one of the slides in the presentation, that sets really some rules about market-based congestion management, about setting up incentives for the system operators to procure flexibility that also tries to encourage the development of aggregation. That is an important aspect for the development of flexible resources. So I would say that it's a good basis. At this stage, the clean energy package is not unfortunately very specific, and this is why there is so much experimentation currently going on, trying to explore in different countries the right the right design, take the right choices in terms of market organization, and then it's going to be also the role of the regulators at a national level to control that the different provisions, directives, and some of the regulations of the clean energy package are applied properly on a national level. And then I would say that the role of the market platforms will indeed be to create more standardization, to reduce the transaction costs, and to create transparency and clear rules that will enhance the participation of flexible resources and really drive the right price signals for such services. So the role of the platforms will be very important, but it needs to also fit in the regulation and in the different choices that will be made at national levels for the implementation of the clean energy package provisions.
Okay, thank you. There are a lot of questions coming in from the audience, which is very good. Let's go through them. There's a question on Dutch research being done by ACM that states that small-scale flexibility finds no business case yet, also not for aggregators. When do you think these small-scale flexibility providers come into play? Do you expect them in those markets?
So indeed, I think this is the direction of history, how we, like we would say in French, that the market and in general the industry is getting more decentralized. So I am not familiar with this specific study. So I would maybe encourage the person who asked it to contact me, and maybe we can discuss in more detail the outcomes. But in general, indeed, the right value for flexibility needs to be demonstrated. The incentives for system operators to use such a flexibility needs to be set up, and the market platforms should provide then the right signals for such a flexibility to emerge. So one thing we are convinced of is that in the future there is going to be more variability. There is going to be less large-scale production with the rollout of coal production, for instance, and the role of smaller-scale flexibility will be key in managing the electricity system in the most efficient way.
Yeah, I have a couple of questions more specifically to the enera project, which I'm sure you can answer. So first one there is, how is verification of flexibility delivery done in this project, and how is then ensured that the flexibility provider actually provided and not just played with the demand to create the problem in the first place?
Yes, a very good question. So there will be apologies. There will be a report published at the end of the year tackling specifically, let's say, the most interesting outcomes and experiences that we have gathered throughout the project, and there will be a specific section on the verification. But in general, it's done as part of a verification platform in the project that was developed by the system operators, and especially the distribution side with EWE nets. And so the idea the rough idea, without going into the details, is to compare a baseline that will be unbiased, and that would be the schedule of given assets without the flexibility activation, and compare it to the actual metering data. And the difference between the two will then be the flexibility that has been delivered and will be accounted for in terms of payment. Of course, it will also be compared to the transactions that took place that should match the difference between the baseline and the real metering data. And then to establish this baseline, it's there are a lot of different concepts. It can depend on the type of flexibility, so it's quite a complex topic.
It is indeed, but thanks for giving this this high-level indication of how you do it, and pointing out the report that will probably provide a more in-depth explanation for everyone who is interested. Let me ask another question on enera, which is about volume. How much megawatt did you have on the platform, and how much is actually procured by system operators?
So we had 360 megawatts of assets that were certified for the participation of to the market. We had over 130 transactions. So the exact figures will also be part of the reports at the end of the year. But in general, the activations were quite large scale in terms of several megawatt hours of transactions in some cases that really led to the alleviation and solving of grid congestion issues for the system operator. So there were some specific test scenarios that were also put in place so that the coordination is running smoothly between the different system operators, and also to really tackle different kinds of problems and different locations where congestions can occur. So I am not able to give a precise figure on the volumes, but this will be part of the report. And what I can say is that there were multi-megawatt hour transactions and even above 10 megawatt hours on some occasions.
Very good. Thank you. I'll ask one last question with the asking you for a short answer to that one. I think that's an interesting one as well. What is the difference with nodes? The overall philosophy seems to be quite similar. Do you think there's enough place in the market for the promotion of several flexibility markets?
So I'm not able. So very good question. I'm not able to really comment on nodes in the specific details. I would say that I think there is a kind of same ideas around what flexibility markets should achieve and what should be the role of the market operators. The fact that there are several platforms, I think, drives innovation very much, in the sense that there is a need to always improve the concepts, improve the systems, and then we will see how the different initiatives and markets and the design consolidate. But Europe, I think there is a lot of different needs throughout Europe, and definitely a lot of challenges to solve. So the fact that there are different approaches and platforms to tackle them is quite positive from my perspective.
Great. Thank you very much, Elies, for these insights, the presentation, and the very helpful answers to the many questions. Thanks again for your participation.
Thank you very much.
Let's now move on to the last, but certainly not least important presentation of today, which is from Frank Wiersma from TenneT. He will talk about the market value of flexibility. Frank decided to focus on the transition to a carbon neutral energy system already back in 2008. Over the years since, his work included front-end development as well as operation and maintenance of major renewable energy projects, including offshore wind projects in several European countries. Since 2012, he is working on the essential building blocks for an integrated energy system in which wind and solar power play a dominant role. He has worked on many national as well as European studies on energy storage, demand-side response, decarbonization heat, as well as the role of flexible conventional generation in the energy transition. Frank joined TenneT in 2017, and in his current work focuses on the future demand for and the potential supply of flexibility resources in an integrated European electricity market. Overall, he has over 20 years of experience, and early in his career, he has built an extensive international track record in water engineering and the oil and gas industry. Frank holds degrees in civil engineering and economics. And I look very much forward to your presentation, Frank. The floor is yours.
Thank you very much, Andreas.
Start with the poll, yes.
Yeah, thank you very much for the introduction. And indeed, if you or one of your colleagues could put on the poll.
I think we can see already the results.
Excellent.
The question was, what will be the main driver for the new flexibility business cases by 2025?
Yeah, now I'm a little bit hampered by the fact that I cannot see the results. So if you could
okay, then
highlight.
I can tell you the results. So most people thought that market matching generation and consumption was the most important driver with 41%, but there were two other ones that were also having a lot of votes, which is balancing ancillary services TSO with 23% and congestion management DSO 29%.
Yeah, indeed. So that's very interesting. Let's keep that in mind for a moment and maybe reflect on that after the core of the presentation, which has a little bit the ambitious title, maybe the value of flexibility. I can tell you it is 42. But that is just kidding. I mean, the important thing is not here a number, but it's about where does this value come from, and I want to talk there about both the value today, how we see that, and how we work on enabling that. But on the other hand, important in my work to look forward into the future. What are the future main value generators? So let's dive into that. So in my presentation, I want to touch on how we work as TenneT now to enable valorization of flexibility today through a number of innovative platforms. Latest development there is new flexibility propositions we are developing to manage a grid congestion challenge that we are facing as TenneT and as the grid operators in our country together with the DSOs. And the second part of my presentation, maybe the second half, really focus on how we look at this anticipated growth of demand for flexibility in this wholesale market. And we can contemplate a little bit the order of magnitude of that potential future demand. And yeah, as to start this presentation, let me say that really we look at flexibility in a quite comprehensive way. On the right side, you see different market segments, using it for system balancing, congestion management, portfolio balancing, also the different users in there, TSO, DSO, market parties. We also consider flexibility quite broad in terms of technologies. It certainly includes demand response, but battery storage, things like flexible hydrogen, green hydrogen generation through electrolysis, industrial demand response, small-scale battery systems, large-scale centralized systems, and also flexible conventional generation today. Of course, having in mind that over time in the future with progressive CO2 emissions reductions, that role of conventional flexible generation has to become ever smaller and in the long term be reduced to zero net emissions. So let's dive into this. And first on enabling valorization of flexibility today. I want to briefly give you an update on two platforms that we are working on and that we've presented. Equigy being the latest, a crowd balancing platform that we have founded together with Swissgrid and TenneT. And it really focuses on lowering barriers for market parties, providing common standards, interfaces, processes for things like validation, etc. Thus lowering the barriers for market parties to participate. And if I say market parties, again, that ranges from aggregators, even potentially local energy cooperatives, or to bigger market parties. And I mentioned these. I mentioned us as co-founding fathers. It's certainly our vision that this community should grow, and also certainly not be limited to TSOs. Now, what are we developing there based on actually quite substantial first steps over the last few years? Sort of a basic IT infrastructure relying on a blockchain implementation that enables the relevant actors and the relevant transactions and key processes that are involved, requesting flexibility bids, activating those bids, verifying those bids, verifying the actual delivery of the flexibility services in a way that's secure, that ensures privacy for the relevant actors, particularly relevant when we come to the decentralized flexibility aspect, and enables relevant users, TSO, DSO indicated here, to leverage those flexibilities. The current vision is let's say an IT infrastructure provided with dedicated implementations in specific countries. So where are we with this? Well, currently we have the use cases TenneT up and running in the Netherlands, AFRR provision through this Equigy blockchain system, and in Germany our colleagues are using it for small scale decentralized flexibilities, participating in redispatch. In the last 2 years, we've developed that and taken those steps with a limited number of market parties in a pilot setup. From next year onward, we have decided to take the next step and make sure that can be accessed by all market parties and offering these AFR balancing services to us in the Netherlands. And the other partners in the project are developing the use cases in their countries. Now, there's a lot more to say with that. So given the time constraint, I will limit it to this, but please visit the Equigy website and you'll find, first of all, more information there, and secondly, the ability to connect to me or relevant colleagues there. Second update I want to briefly mention is GoPax. 2 years ago, indeed, we were presenting GoPax as part of the overall rollout at the FLEXCON conference in Brussels. For those of you not yet familiar, a common TSO-DSO platform for market-based congestion management that firstly aims to enable lowering barriers for participation for small-scale flexibilities, and secondly resolves or provides a way to coordinate this between TSOs and DSOs. We're developing this together with almost all Dutch DSOs, all the main ones. And this focuses today on enabling redispatch, combined bids to alleviate grid congestion constraints, combining buy and sell bids in different parts of the grid to affect those flows based on indeed individual grid constraint forecasting by each grid operator. Going on, so it's important that it's not only through GoPax that these opportunities congestion are growing. In general, the congestion challenge is growing in our country, and also we have worked hard together with the DSO colleagues to develop a proposed grid code update that really improves the framework and possibilities for congestion management, particularly also by the DSOs, as well as for us as TenneT. So with that, we envisage this, the growth of this will be substantial. Our current use case at TenneT has been now up and running for 3/4 of a year at the next scaling level. When I was here 2 years ago, I talked about, and my colleague Peter Hermans then, the earlier pilot that Steding carried out, and we are expecting now very soon the launch of the use case of Alliander in a DSO grid congestion location at Nerijnen. So this is a platform that has really grown from a first pilot. It's been very much a learning by doing approach, and we see that for us as TenneT, certainly also with the DSO colleagues, this actually doing it and learning it is the most effective way to build the resources, the processes, etc., within all of our organizations to actually do this and to meet the rapid growth in the actual challenge that we see in the grid. So for more information, also I refer to the website. Please also note there the market information subpage on the GoPax website, where you'll find quite specific information on the volumes and transactions that have taken place over the last months. You see that there is those volumes are quite substantial. There have been periods where on the TenneT grid, let's say, we have managed gigawatt hours through this within a day. But you also see that very much depends on the actual timing and situation of grid congestion materializing. So it's certainly not every day. But if you scroll on that market information site and go look a little bit at the last month, you get a fair impression of where we are. And again, we're expecting to, particularly the use case of Alliander, to add to that in the very near future. Yes, so beyond these platforms, we're also working on developing new flexibility propositions. That's really about product specification and the way in which we organize procurement and definition of flexibility services by market parties. This is not separate from at the moment. This is a pilot project by itself, separate from GoPax. But thinking back to GoPax, we very much see that as a sort of a common foundation for managing congestion. So personally, I would not be expected if the results of the future project in the end will also be implemented in the longer term or the medium term on this same foundation. But what are we trying to do here? Have really enabling flexibility as sort of a long-term alternative for grid investments in case of congestion. I should emphasize here, it was very good to note Elias' comment there before. At the same time, of course, we are really scaling up our investments in the grid. So this is not the long term doesn't imply that it's a full solution, but there are situations where grid investment is a relatively expensive solution because, for instance, the congestion only takes part a limited number of hours per year, where we expect the flexibility solution to be much more cost effective even in the long term. Now, where does this pilot project take place? It's really focused on the north of the country, particularly the areas where you see in black lines are 110 kV grid, where over the last years, really substantial volumes of new, particularly large-scale solar PV generation has been grid connected. And of course, that's also had solar PV generation really showing a relatively peaky profile in terms of high gigawatts capacity over a limited number of hours a year. So where we see that potentially in these applications, flexibility can play an important role, cost-effective role. What is the focus there? On the one hand, making sure we organize and define this in the way that's really technology neutral. We want to make sure all types of demand response, battery storage, hydrogen production, smart charging EVs can participate in this. It's also good to note that in that north part of the country, there is a substantial industrial cluster as well. So we want to make sure we do this in a technology neutral way, and we want to make sure that this can coexist very well and enable the kind of value stacking with wholesale market demand for flexibility. I'll expand on that later. We think there is a large degree of correlation between, for instance, I mentioned the solar PV generation, where there's value in the wholesale market by being able to a lower peak in feed and sell that energy at a later time, for instance, the night that follows, which is a functionality that's very much correlated in system value, and thus it should in these pilots also materialize as a financial value to coexist, let's say. So where are we in this? Last year we've done quite a comprehensive market consultation with a large number of market parties, making sure we understand their requirements and fully focus on enabling this technology neutrality, for instance. And we've now decided in the next years, and this is now fully in preparation, to come with a tender to this market for the first 100 megawatt capacity to be procured, which is still a pilot, of course. We envisage that would, in case with success, that can further grow over time. And so this is just an example. We do it in the Netherlands. In Germany, there's a parallel comparable project called the Grid Booster. Due to time, I will not dive into this, but if you contact us, we'll be happy to provide you with more information on that. So then I come to the second part of my presentation, and here I want to take you along in a little bit of a somewhat maybe detailed technical story, supported by some graphs and some quantitative information, but I think it gives you a good, helps us to get a good sense of what is this, why do we see the future of flexibility primarily or largely driven by this wholesale market, which is really a shift from where we are today. So I'll do this by looking at some graphical information that we did based on analysis over the last years, particularly driven by our recent or last year's climate agreement that sets 2030 decarbonization targets, and which include, not as a firm target, but as an expected outcome, approximately 70% wind and solar generation contribution in the total generation mix. And that means, what I want to show you, illustrate that wind and solar will dominate the wholesale market by 2030. So what you see on the right is a picture where we look at historical weather. So this is the weather for February 2012. You see 2 weeks, so with a slightly lower demand profile in the weekend days and in between the 5 weekdays with some higher demand, as envisaged, modeled for 2030. And let's now look at over those 2 weeks with this historical weather, what would a February 2030, let's say, potentially look like. So here first in blue, with this historical weather, the expected wind generation contribution in the system. We are talking then by 2030 some expected installed volume, something of the order of 10, 12 gigawatts offshore wind, something like 6 gigawatts onshore wind. And of course, in addition, solar PV, where we expect another installed capacity of the order of 16 gigawatts or something of that order of magnitude. Of course, we are in February here, so that you see the relative contribution of the solar peaks and doesn't reach that full installed capacity, relatively low solar intensity typically in the winter. So what we then see is that there is a lot of variability in the system. There's hours, days, particularly in this first week, a few days in the where consistently solar and wind generation exceeds the demand. There's also shorter term mismatches. For instance, the end of this first week where there's some shorter peaks, and you see a second week, this graph where there's really quite a persistent period of shortfall for renewable generation. So let's look how would this influence the market, and how can the wholesale market work efficiently to bring demand and supply again in together, because this is sort of the starting point. Of course, the function of the market and the system is to then make sure we again match generation in feed and demand every second. Also, I should emphasize that I show here consumption, but that's sort of the sort of ex ante consumption before we consider demand response, and I will come to that in a moment. Yeah, and so our basic statement is flexibility is really key to limiting the potential that you could get for curtailment in case of these excess hours, and on the other hand, the need for fossil generation whenever there's these persistent shortfall periods. And I'll try to illustrate that further. Now, to be able to do that and not overly complicate the picture, let's say I'll just show all the renewable generation as one block in green here, and then illustrate how flexibility can serve to bring those together. So first to that, I want to introduce the concept of short-term flexibility resources. And with short-term flexibility resources, we mean not that these would play a part only the next years and not later. These will be in the system every year, but their functionality is shifting maybe from demand response, demand from hours, between hours, within a day, for instance. And battery storage also can be a very efficient way of shifting in feed from peak daytime solar in feed, for instance, to night. But what's important there in these short-term flexibility resources, these do not add net energy to the system. It's just shifting over time of energy. And well, we did some modeling how this short-term flexibility can play a role, and then come to this picture. You see in pink here how short-term flexibility in feed can help to particularly fill the shortfall periods. Then you have to imagine that whenever the green renewable generation exceeds demand, imagine a battery system is filled, and then a little bit later, when there are shortfalls in pink, the same energy is fed back into the system. And to see a little bit this behavior of the short-term flexibility in feed, you see the representation in the pink line at the top, where you see hours of absorption of energy and hours of giving back energy. Now, the easiest way to imagine this is indeed with a battery, but I want to emphasize that we very much see demand response in the same cluster of functionalities, basically taking away demand from some hours and concentrating it in other hours when this in-feed peak occurs. You can also see that, of course, it depends very much how it plays a role, what kind of capacities in terms of gigawatts, in terms of storage capacities, if it's a battery, are in the system. Now, in this picture, we have assumed simply to be able to show something, 6 gigawatts of installed capacity in short-term flexibility resources, and well, which comes out of our analysis.
Sorry to interrupt. We need to move ahead a little bit quicker because we are actually already approaching the end of the session. Thank you.
Yes, you're giving me a challenge. So I want to show that even though you see these batteries or short-term flexibility resources are not able to completely match demand and supply, but it provides important contribution. Even for this contribution, we need something of the order, from our analysis, 5 to 7 gigawatt installed capacity, including, I say installed capacity, including demand response, and the order of 25 to 70 gigawatt hour in terms of energy volume. So this is really very substantial already. And of course, this in-feeder return will come from, will be driven by price variability in the wholesale market. So secondly, let me add long-term flexibility resources, which will be needed to complete the picture, which includes like possibly still demand response, but then in hybrid systems. So this can be persist over time, but also today gas-fired power generation, things like electrolysis. And you see that then enables to make sure demand is met at every time. You also see that this short-term, long-term flexibility plays a role in making up persistent shortfalls, so that also at the battery systems, the shorter-term flexibility resources can play their role in bridging shorter-term fluctuations. Well, so my key message is that it's interesting to a little bit play these games in the model and get a sense of order of magnitude, and then it becomes clear that the number of gigawatts, the number of gigawatt hours are such that this will be a huge, and this huge pool of flexibility, in our view, subsequently also creates a lot of opportunities to leverage the same flexibility resources, maybe at the same hours or the next day, for meeting congestion management and system balancing challenges, let's say. And with that, Andreas, you'll be happy to learn. I'll come to the end of my presentation, just summarizing the key takeaways. So we're focused today on making sure we create new opportunities for market parties to valorize, particularly decentralized flexibility with the platforms that I mentioned. We do envisage, and we want to prepare for this transition towards the main future demand growth, the bulk of the demand coming from the wholesale market. And we need to focus on fully enabling this, for instance, working together with DSOs on fully making sure smart meter data can be used for allocation, etc. And we really see it as important that there's this seamless co-optimization of flexibility and value stacking and flexibility across purposes, wholesale market, TSO, DSO, and balancing. And with that, I come to the end of my slides.
Very good. Thank you very much, Frank. We have one polling question that we will have run in parallel whilst I already asked a couple of questions, because we are already slightly behind schedule, but I think there's a couple of questions that are quite interesting. Of course, you did say 42 was the answer to the value. I was hoping you could be more precise, but that's of course a very difficult answer. But maybe you can ask in general, you can answer in general the question around, if you open up markets now for more liquidity by new market parties, this will of course increase competition, and the question is then, will this actually drive down prices and value of flexibility, or do you expect the demand to grow maybe even more, such that there is actually value for participants to get into this?
Yeah, I very much see that dynamic. And indeed, it's two forces that are driving in different directions. I don't think we have a firm outlook on one of the forces dominating the other, but we do see that our actions can make a difference there, and particularly actions that, for instance, have to do with making sure flexibility resources, decentralized flexibility resources have very cost-effective, low-cost, and convenient access to the market. Also by aggregators, small parties, big and small, lowering those barriers can really help to drive supply up. Yes, that will enhance competitiveness, which is, I think, a very useful mechanism to come to this kind of optimal combination of technologies, which of course also over time, as maybe demand response through automation can become more cost effective and cheaper. On the other hand, technologies like battery storage becoming cheaper is an important mechanism to come to an optimum mix. At the same time, it's clear, particularly in the congestion management market today, and I think this wholesale market in the future, and I think we're in 2025, we'll already live in a different world then there. Yeah, that demand growth is also substantial. That's clear. It will be interesting to see the outcomes of that.
Yes, thank you very much. And we also have the outcome of the polling question, and the answer is clear. The almost majority, 48%, says regulatory barriers are to market access are the main barriers to flexibility business today, which is also a clear and interesting outcome. Often it's not the business or the technology that is the problem, but the regulatory setup. In that context, I think it's also good to have projects like the ones that you showed us to also explore regulatory impacts. One question that was asked by the audience was, on a technical level, why did you use blockchain as a platform for equity?
Yes, if you allow, I'll still touch on the regulatory side for 1 second, because yeah, indeed we see that also as an important step, which is why we really invested a lot of effort together with the DSOs, also market parties and regulator and policymakers to come to this proposed update to the congestion management part of the grid code in the Netherlands, and we really have high expectations that once that's finalized, opportunities will be much better. Then to the question on equity. Actually, we have explored a number of technologies, and also the blockchain is not the only solution or the standalone solution. In parallel, we've worked on on pilots like enabling communication through the mobile network for decentralized assets as well. But we do see that the blockchain infrastructure can play a very important role in ensuring security, a degree of anonymity, of protection of privacy, and trust among all the parties, knowing that the number of both the buyers and the sellers, if you will, of suppliers of flexibility will become numerous and will also become range from big to small. So basically ensuring that trust is something we have to warrant for the future.
Very good. Thank you very much, Frank. I think given the time, I would like to conclude this session. Thank you, Frank, for your presentation and valuable insights here. And now we also come to an end to the session today. I will attempt a very quick summary given the time. I think we learned a lot about how to design and got new ideas how to design system services and how they can be procured from Helena at the very beginning. She also showed that it requires new thinking when it comes to ensuring that in the future not only the conventional power generators can participate, but also new players, renewables, demand-side flex, and storage can participate in those markets. Then we first heard from Hallstein how Nodes was going about rolling out flex platforms and what hurdles they had, and also then afterwards from Elies from EPEX SPOT what they did, and I think both of them encountered similar challenges when it came to incentives for DSOs, TSOs to actually move on to these kind of platforms, and also they identified that the biggest hurdles are that these incentives and the cultural changes that are required need to be tackled in order to move forward. And then last but not least, we heard Frank from TenneT telling us that, of course, flexibility will have a value in the future. There's a big need given the change in generation mix. And he also showed us how TSOs and DSOs are exploring further technical projects to enable also new players to be part of this market. I would like to close it with that by thanking the audience for participating, and in particular also the speakers for your very interesting presentations. Thank you very much for that. Last but not least, I would like to make the note that we have further conference sessions in the FLEXCON conference 2020 in the next Wednesdays to come. I think there's 2 or 3 more sessions each Wednesday. Join us there, and I hope you all learned something new today, or many things new today. I certainly did. Thank you very much, everyone. Have a good remaining day.